Alright, so today I'm going to teach you about trig substitution, which is a method of integration, a lot like U substitution, or where we set a part of our integrand equal to something else that would make it easier to take the antiderivative of. So instead of setting U equal to, say, 2x minus 1, we're going to set something like sine squared of x equals, our 2x minus 1, or whatever, okay? So the best way to kind of explain this is through an example. So let's start out with the integral of, let's use x squared plus 1 to the negative 3 halves dx. Now, we can't do a U substitution because the derivative of this can't be found elsewhere in our integrand. So the derivative of this, which is 2x, there's no x dx anywhere. So it would be impossible to do U substitution. However, we can do a trig substitution. So we need to look in here and see what's familiar. What makes us think of a specific trig function? What could possibly lead to a substitution? So whenever you have something squared plus 1 or 1 minus something squared, you should immediately think Pythagorean identities. So our Pythagorean identities are like sine squared theta plus cosine squared theta equals 1, or maybe 1 plus tangent squared theta equals secant squared theta, or cotangent squared theta plus 1 equals cosecant squared theta. So which one of these looks like this? Well, one of these two definitely. And let's try go with a tangent one, because it seems simple. So we want to set x squared plus 1 equal to 1 plus tangent squared theta. Okay? So if x squared plus 1 equals 1 plus tangent squared theta, well, wait a minute, we can simplify this. Minus 1 from both sides, so we'll have x squared equals tangent squared theta, and then take the square root of both sides. Square root of x squared is x, square root of tangent squared theta, it's just tangent theta. So hey, that's pretty simple. So everywhere we have x, let's just put in a tangent theta. So we have integral of tangent squared, because it's x squared, so it'll be tangent squared theta plus 1 to the negative 3 halves dx. Now wait a minute, this is dx. We need it to be in terms of theta. So to find the relationship between dx and d theta, let's just take the derivative of our stated relation of x equals tan theta. So the derivative of x is dx, and the derivative of tangent theta, well, that's secant squared theta, d theta. So everywhere we have dx, let's just plug in secant squared theta. So I have the integral of tangent squared theta plus 1 negative 3 halves times secant squared theta d theta. So wait a minute, tangent squared theta, that equals secant squared theta. So let's just substitute that in. So secant squared theta, the negative 3 halves, times, and let's just write it secant squared theta as secant theta squared d theta. Okay, well, we have two terms with the same base, and, well, wait a minute, our bases aren't quite the same yet. So let's simplify this. Secant squared to the negative 3 halves. So we have power raised to the power, so we multiply. So negative 3 halves times 2, well, that becomes secant theta to the negative 3 times secant theta squared d theta. Well, hey, same base, we're multiplying, we add the exponents. So this becomes secant theta to the negative 1 power d theta. And so this basically means the reciprocal of secant. So 1 over secant theta d theta, hey, wait a minute, the reciprocal of secant, that's cosine. And we all know that the derivative of cosine, the integral of cosine is negative sine theta plus our constant of integration. So now, okay, so this is in terms of theta. We want it in terms of x. What's our relationship between theta and x? Well, we know x equals tangent of theta, so what's sine of theta? So if x equals tangent theta, what do? How do we find out what sine of theta is? Well, we know that, let's make our triangle, okay? This is a triangle, and this is our angle theta. If tangent equals x, and tangent equals opposite over adjacent, then can't x opposite leg, our angle be x, our adjacent leg be 1, well, that means our hypotenuse would be square root of x squared plus 1, right? Hey, kind of looks like that. Interesting, not a coincidence. So our tangent of theta is opposite over adjacent, so it would be x. Our sine would be opposite over hypotenuse. So it would be negative x over square root x squared plus 1 plus c. So that is our answer.
I'm Stuart Jeffries. I'm a professor in physics and astronomy at the University of Hawaii, and I'm associate director here at the Institute for Astronomy on Maui. What I do is I'm a researcher, and I research into solar physics and also imaging.
Do you feel that the math education you got in high school and then in college prepared you adequately for the field you went into?
I don't think I could be in the field I was in if I hadn't done the math in high school and college. I think I'd be struggling. One of the things that I think it's important that you don't have to remember everything about physics and things, but as long as you remember your basic principles and you've got some math, you can start from basic principles, use your math and build up to, the problem you're dealing with.